So for this one, here's the big thing we've got to know.
Like they let you come the first walk and then they
Okay. All right. So standard position. Here's some of the basic ideas, basic definitions. You got to have these in place because they're going to talk about this stuff and keep bringing back to what we're talking about here. So very first thing is they're going to talk about standard position, and basically what standard position is this, and we got to go through the definition here. So it's when an angle has the vertex at the origin and one ray is on the positive x-axis. One ray and one, oh yeah, I didn't put the word in there, did I? Sorry about that. And one ray, my bad. Okay, and this x-axis, positive x-axis that we're talking about, that's what they're going to call the initial side because that's where this thing has to start. All right, so angle has the vertex at the origin, and again, when we're talking about the origin on our unit circle, that's basically that's what that x is. It's in the middle of it. That when we're talking about, that's starting like right here in the middle. That's basically like our origin point that's here because this is your x-axis, this is your y-axis. So this is just taking an xy coordinate plane and just doing this part with it. So one ray is on the positive x-axis, which they call the initial side. The other ray can be anywhere. So they don't say where it is. They're just going to say the other ray is called the terminal side. Okay, it's the ending point. It's where you're going to go. It's where you're going to stop to kind of go through this thing. And I guess the very first thing they're going to have you work through in this one is you have to sketch some angles. And when you're sketching angles, basically we've got two different types of angles that we're looking at. Yeah, I left a few words out there, kind of made it messed up there. So we'll make sure this is a little bit better. All right, so when you sketch angles, positive angles are drawn up from the initial side. And then negative angles. Well, if positive goes up, negative's got to go down, right? Okay. Now, what they're going to, and you're maybe saying, well, how in the world are they going to do that in Math Excel when we're doing through this? Basically, and now we'll show you somewhere if you have to do this by hand, we'll have this part. But in Math Excel, they're going to give you four choices of, okay, sketch a 30-degree angle, and you got A, B, C, or D. You just got to figure out which one it's going to be on this one. So if they ask you to do something like this, you have to sketch a 30-degree angle. And with Math Excel, it should be somewhat color coded so that it makes things a little bit easier. And first thing is they'll give you an XY coordinate plane, just the axis. You have X axis and the Y axis. And then you should always have one you should always have the initial side that's drawn like this. If they don't have it drawn like that, then you can automatically kick that part of the multiple choice question out, because you have to have one that goes from here at the origin over to the right side. And since it's positive, the arrow has got to go this way, and they should have an arrow that will show it going up like that. And then it should be just something close to 30 degrees. And from what I can remember seeing on Math Excel, most of the time they have the angles drawn in red. That way you can easily kind of pick out the angles that you're looking for there. All right, and the only difference is if it was a negative 30-degree angle, you've got to sketch instead of a positive 30-degree angle. You're still going to start with the initial side being the same way.
Teachers and students, pardon us.
Okay, so you still got the same initial side, but again, if it's negative, the arrow is going to be drawn going this way. And now we're going to go down 30 degrees. Okay, and that's the big difference you've got to kind of see, is that where the arrow is from the initial side. If it's going this way, you know it's positive. If it's going this way, you know it has to be negative. All right, now the other thing they may do is they may not give it to you in degrees. They may give it to you in radians, which is where we're going to have the pi part of this one. So it may be that it's got sketch 3 pi over 2. Okay, and again, the one thing that always has to be true is that when you're doing this, when you always have it drawn from the point here over to the right, from the vertex, it's positive, so we know we're going this way. And if you're kind of still struggling with 3 pi over 2, and you're like, I don't know what that is, that's one where you look on the unit circle, and you find out that 3 pi over 2 basically is the same thing as 270 degrees. So when it says sketch 3 pi over 2, really you just want to think that, okay, that's the same thing as 270 degrees. It's positive, so we know we're going this way, and we'll go around till we get to the 270 degree mark, and then we'll stop right there. All right, and again, with Math Excel, what they will wind up doing in a lot of cases like that is they'll give you, for like your 4 multiple choices, they'll give you the correct one, which is what we have here, obviously. They'll give you another one where that maybe it's like this, and they'll have it drawn so that you're doing something like this. They'll have another one that will start here, and it'll go here. So that it would be like this, and they'll have another one where maybe it's here, and you're just going to there or something like that. And they'll just say, all right, pick the correct one, A, B, C, D, that kind of a thing. So the main thing is you always got to have your initial side going to the right side of it, which this one's going to the left, so that one's out. It's got to go up, so that one's out, and then both of these are going down. Now, in that case, they may give you one that may not be. Let's sketch one more this one. So let's do negative 5 pi over 4. And you're probably going, well, I don't, that's, and again, when you're first doing this first couple of days, and it might even take towards the end of the week before you get to this one. When we're sketching 5 pi over 4, you're probably going to go, I don't know what 5 pi over 4 is. So you're going to take out your unit circle. You're going to find 5 pi over 4, which is right here. That's 225. So you just got to know that if we're sketching this thing, that's negative 225 degrees that we're going to sketch. All right, so we know we're starting here. It's negative, so we know we've got to go down. All right, and this is the other part we're going to kind of work on just a little bit. If it's negative 225 degrees, if we go to here, that's negative 90. If we go to here, that's negative 180. So if that's negative 180, we got to get to 225. That should be about in the middle, right there. And I know somebody's thinking, well, they're going to give you one that's like that, and are they going to give you another one that's like this, where it's drawn back to here? No, there should only be one that's anywhere close to what you have, because they can make the answers be, you know, 4 different things that could spin off the 225 in some way. Okay, so again, big thing is, if it's negative, you're coming down from the initial side. If it's positive, you've got to go up from the initial side. And they should have it drawn with the arrow to kind of help you know which way it's going to go for that one. If they don't give you an arrow, if they just gave you an angle that was like this, and they said, okay, tell me what that angle is, you don't know, because they have to give you some marking of something somewhere, and they got to give you some direction to go of where this thing is going to be. Okay. So that's, again, just kind of backing up to make sure that we've got standard position, the positive and the negative angles with this thing. The next thing they kind of throw at you, which is just, again, spinning off that one a little bit, is coterminal angles. Okay. No, same thing. Okay. So back here when we're talking about terminal side, does anybody know what we're talking about with terminal in this case? When you go to like a bus terminal or a train station terminal or an airport terminal, you know what terminal means in that case? Terminal most of the time means ending. So, if we're talking about the initial side back here, that's where you started. The terminal side, that's where you're going to end in this case. So when we're talking about a co-terminal angles, it's a co-ending angles. So basically, it's angles that end at the same location. So when I talk about airport terminals, I know sometimes it's where you're taking off, but at the same time, somebody's takeoff point can be somebody else's landing point, right? If you're at gate 12 to take off, somebody eventually is going to enter through gate 12 to get, to wherever you're going. So it's kind of that same thing. If you're flying to Atlanta and that's your terminal, place that you're going, your terminal location, somebody else that's their beginning location. So you can kind of say that's kind of what we're looking at in this part of it. So co-terminal angles that are going to end at the same location, same spot, same location, same side, whatever you want to call that thing. And basically to do this, to find a co-terminal angle of a positive angle, you just have to do one simple little thing. You just have to subtract 360. And then to find a co-terminal angle of a negative angle, you just add 360. Okay. Now, they're probably not going to ask you to do both these, but we're going to go ahead and do both here at the same time. Let's say we have to sketch a negative 135 degree angle. And then we're going to name a coterminal angle. All right, so just a quick sketch. There's our XY axis. So again, initial side is going to start here and go this way. And again, because it's negative, we know we've got to go down. And sometimes people are like, well, if it's negative 135, how far down do we need to go? Here's where we can kind of do both of these. If we actually get the coterminal angle first, if it's negative 135, and we got to name a coterminal angle, then what we said, if it's a negative angle, we're just going to add 360 to it. That would be 225 degrees. So negative 135 this way is going to end up at the same angle as 225 degrees if we go this way. So basically that's going to put us right there at that 225 degree mark, which means it should be something like that. So negative 135 and 225, basically they're the same angle. The only difference is negative 135, you're going to go this way. And then 225, you would be going that way. But you wouldn't, and again, for sketching it, you wouldn't have to sketch that part of it. We'll just sketch the other part there. Okay, so that's what they're trying to get you to see is that there's two angles. They're going to be the same thing. One of them's going to be negative, one of them's going to be positive. They're still going to end in the same spot. It just depends on, is it positive or is it negative? So again, if it's negative 135, it's going to end in the same location as the positive 225. It's just depending on which one they give to you. All right. So then what they're going to do is, besides having you sketch a bunch of these, so we've got, there's the sketch of the negative 135, and then there's our coterminal angle. That after this, they're probably going to ask you for a lot of these, just to name a coterminal angle. And then they're going to give you usually a couple of stipulations of this one. They're going to say, all right, just so we're all on the same page, let's make sure that the angle is going to be between 0 and 360. So we're not going to sketch these. We're just going to find it. We're just going to name what that angle would be. And this is part, some of y'all are asking about, will we ever have to worry about any angles that's not on the unit circle? In this case, yes, because this part, they may just throw anything out there at you. So it could be that maybe it's like negative 280 degrees. Because you're not having to sketch anything. This one, you're just finding it, so you don't have to worry about the unit circle in this case. All right, so again, the number is negative. So to find the answer, we're just going to take that negative angle and just add 360 so we can make sure that that number is between 0 and 360. Add those two together, and that is 80 degrees. So negative 280 and positive 80 would both end at the same location. The only difference is one of them is going to go down, the other one's just going to go up. All right, let's say it was 450 degrees. Okay, again, it's positive 450, so we've got to get it down between 0 and 360. So in that case, we're going to subtract 360 from it. So it'd be 90 degrees. So positive 450, 90 basically winds up at the same location. It's the same thing. All right, let's do negative 560 degrees. All right, so negative 560, just going to add 360 to it. In that case, it winds up being negative 200. Okay, but again, the stipulation was this number has to be between 0 and 360, right? It's not there, right? So if it's negative 200, what do we do? Still negative, right? So we just add another 360. So just keep adding 360 until eventually you get a number that's between 0 and 360. So if you add 360 one time and the number is still too small, just add it again until eventually you get to a number that will get you between 0 and 360. Sometimes you might have to add it 3 or 4 times depending on how big or how small that angle may be there. All right, now here's where the fun kicks in. Well, if it's negative 11 pi over 6, and you're thinking, well, how in the world are we going to add 360 to that? Well, you can do it a couple of different ways. You know, the hard way, the easy way. Easy way. Okay, glad that you said that because I don't want to do the hard way. All right, if it's negative 11 pi over 6, what is 11 pi over 6 in degrees? 330, right? So if you've got negative 11 pi over 6, this is really the same thing as negative 3. Oh, it's not working there. Yeah, that's the same thing as negative 330 degrees. Well, if it's negative 330, just like we're doing over here, if it's a negative number, that means we've got to add 360 degrees to it. That'll get us to 30 degrees. Now, here's the catch with this one, though. If they give you the number in pi over something terms, they want the answer also in pi over something terms. So in that case, if you got 30 degrees, you go back over here and say, all right, 30 degrees. Oh, that's the same thing as pi over 6. So this answer would be pi over 6. So just take the number that's in pi terms, which is radians, figure out what that would be in degrees, and then from that point, you either add or subtract 360 to that, get the answer you got, and then we're going to convert it back into the radian measure to get there. Okay, Daniel. Yeah, if they ask for the answer in radians, then yeah, it would be pi over 2. Now, and this answer, they would probably, well, actually, we'll show you that here next. That if it's one of these numbers that's not on the unit circle, we'll actually show you how to get that number, and that's the next thing we're doing here, is to tie all that together. That if it's on the unit circle, that's easy. If it's 90 that's here, you just go back over here and go look. All right, 90 that's pi over 2. Okay. If it's a number like this where it's not on the unit circle, we'll show you how to get there and how to get that thing changed from degrees to radians, whatever you need to do. Now, the question that y'all were asking earlier, though, are we ever going to have to worry about finding like sine or cosine or tangent or any of these things? No, you're not. The only thing I'm going to ask you for as far as finding like sine or cosine or tangent is just going to be using these numbers here. It's going to be some multiple of 30, 45, or 60 or 90. I'm not going to ask you to find cosine of 80 degrees because you're going to go, well, 80 is not on here. Yeah. So in that case, I'm not going to ask it. This is all stuff that if we're doing like we're doing yesterday, if I'm going to ask you for a sine or cosine, it's going to be a number that's going to be on the unit circle. Okay. And then so the last thing we're doing today is for the numbers that may not happen to be exactly on the unit circle, we're going to show you how to convert those numbers so that you can find out what those numbers are going to be. So we're going to show you how to convert. Let's go degrees to radians. All right. And again, degrees, radians is anything that's got to do with pi. Normally, occasionally they'll sneak one in where they won't put pi in there, but basically when you think about radians, think about something that's got pi in it, because radians, degrees is the degree measure, which we're used to turning. Radians is the distance that you got to think about. So that's kind of the difference of the two things that's here. One of them is degrees, one of them is like a distance, if you don't think about it that way. All right. Two simple, easy things to do here. If you give something in degrees and you got to convert it to radians, all you're going to do is you're going to multiply by pi over 180. And then the next thing you're going to do is you're going to simplify if it's possible. Sometimes you're able to simplify, sometimes not. I would say almost every case you'll be able to simplify at least one something out of it, whether it's a 2 or a 3 or a 0, because 180, you got a million different numbers you can divide into 180. You can do 2 times 90, 3 times 60, 4 times 45. You can do 5, you can do 6. Can't do 7. You can do 8. No, you can do 8. But you can do 9, 10, 12. There's a ton of numbers you can divide out of 180. So the chances of simplifying a fraction in this case is going to be a lot when it comes down to it. So. All right, so let's give you a number that's not on the unit circle, 40 degrees. All right, so I'm going to ask you, all right, convert this thing. And you're going to go, but that's not on the unit circle. Exactly, which means you got to use your formula for this part of it. All you're going to do is you're going to take that 40 degrees that you have, and you're going to multiply it by pi over 180. That's a terrible multiplication symbol there. All right, and if you do that, basically you can just cover up the pi for a minute. You've got 40 over 180. What can you divide into both 40 and 180? All right, 10 would work. 2, 20 probably is your biggest number. So you can divide them both by 20. And then that makes it 40 divided by 20 is 2. We've got our pi number here. 180 divided by 20 is 9. So it should be 2 pi over 9. And again, if you happen to not seen that it was 20, if you hopefully by ending in a 0, you can go, oh, we can cancel out the zeros, and make it 4 pi over 18. And then you go, oh, they're both even. I'm dividing both by 2. And then that would get you to 2 pi over 9. So whether it takes you 1 step or 2 steps or 3 steps, it doesn't matter. As long as you get it simplified down to the correct lowest number, you're good to go. And usually somebody says, what if it's negative? Well, don't be scared of it. I know we're coming from Halloween, but don't be scared of negative numbers. So it's negative 50 degrees. It's just negative 50 and then pi over 180. And again, really all you're doing is you're just ignoring the pi for a minute. If it's 50 over 180, again, the obvious choice to me on that one is always just go back and cancel out your zeros. And that would make it negative 5 pi over 18. 5 won't go into 18, so there you go. So if the answer here is negative, the answer here also needs to be negative. That's all you're going to do. Just bring the negative sign over when you simplify. All right, let's give you one that doesn't end in 0. Make you think a little bit. Let's go 222 degrees. So that's 222 pi over 180. All right, for that one, they're definitely even. So divide them by 2. That makes 111 pi over 90. If it's 111, we know it's not even, so you can't divide by. Oh, if you think back to what we were doing before, we were doing the factor trees and doing the stack method, do all this stuff. That if we were going to simplify these things, we went through and divided everything by 2, which was our smallest number. If it's an odd number, we're going to check 3s, right? So if you check 3 will go into 111. Doesn't seem like it would, but when you add them up, you get 111. That's 3. That's going to make it 37 pi over 30. And in that case, Just leave it like that. You don't have to worry about making it into a mixed number or anything along those lines. Okay, now the two you have to do, that's a hard one, which you may be going, well, that's not really that hard. It's not. Here's the easy one. Go in the other direction. We're going to convert radians to degrees. So there's only one thing to do in this case. There is no simplifying. You're just going to multiply by 180 over pi. So this is basically just a calculator question because there's nothing else to it that you have to do. So if you're going degrees radians, it's pi over 180. Radians to degrees, it's 180 over pi. Because again, they're opposites of each other, they're inverses. So we're just flip flopping on these. So this would be one of those where, again, if you have a number that's not on the unit circle, if it's 9 pi over 5, you just take that number and then you multiply by 180 over pi. Okay. And this is where your chemistry people, this is where you get to cancel out stuff, right? When you do conversions, you're trying to cancel out some of the common units that you have. So in this case, we're talking about pi being like, not necessarily a unit, but it kind of sort of is. You cancel out your pi's. Now you're just using your calculators. Now it's just 9 times 180 divided by 5. Punch that in your calculator. That comes out to be 324 degrees. All right, now, if it happens to not be a perfect whole number, let's say it's negative 7 pi over 13. So we got to multiply by 180 over pi. And again, big thing in that case is we're going to use that to cancel out our pi numbers. And from there, you're just going to use your calculator because, I mean, again, you don't get to use your Casios. So we're practicing with our TIs here, our Texas Instruments here. It's just 7 times 180 divided by 13. So it's negative 7 times 180 divided by 13. Comes out to be a decimal number, 96.9 something, 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 something. They should tell you to round this thing off to ever how many decimal places it is. So it's negative 96 point, if we go one decimal place, negative 96.9. Again, they should tell you whole number, one decimal place, tenths, hundredths. That they'll tell you what to round this thing off to. If it's not a whole number, they kind of clue you in on that one and see what it's going to be. Yeah, is that good? Is that better if I move it that way? Is that better? No. How about like that? All right, now one more here. And we got one of the little bitty tiny formula. Because they might sneak in and give you one of these numbers that's in radian form, but it doesn't have pi in the number. It's just 4.954. What do you do? Well, in that case, you still do the same thing. You take that number, you multiply it by 180, and then you divide it by pi. Now, there is no pi to cancel in this case, so that's one where you would just, punch it in on the calculator. So it's 4.954 times 180 divided by And they'll either tell you to use your pi button, or if sometimes on some of these problems they may tell you to use 3.14. But if they don't say do that, then you're just going to assume that we're going to do pi, and it's going to mess up. I know it is. And that comes out to be 283.8 for this. May be one where, again, they may tell you to round it off to the nearest whole number. So it's about 284 degrees. But again, they'll specify tenths, hundredths, thousandths, whole number. They'll tell you what to round this thing off to, and they'll tell you whether to use pi or whether to use 3.14, because it does make a small difference in those numbers. If we did 4.954 times 180, if we divided that by 3.14, 283.9. Or the other way it would have been, or actually that would have been 284.0. The other one would have been 283.8. So it wouldn't have made a big difference, but it would have made a small difference there. Okay, and then very last thing, and this takes a really short amount of time here. Okay, so they're going to ask you to find an intercepted arc. You're going to multiply the radius by the angle. All right, the way they do the formula for this thing is they're going to say S is equal to R, which is your radius. The angle in this case, they're going to call it theta, which looks like an O with an extra squiggle in there. Yeah, so your radius is R, your angle is what they call theta. We do alphas and we do betas and other stuff, but then they throw in theta for angles on those. And then S, that's your intercepted arc. I don't know why they call it S, but that's just what they do. All right, now these questions will be like so easy, I almost hate to give them to you, but we're going to give you a couple just to make sure that you got it.
Can you move the paper up a little bit?
Mm-hmm. Okay, so they're going to give you an arc, a chunk of the circle, and they're going to ask you, okay, find the intercepted arc. And for this one, your radius right here is 11. The angle is what they're going to give to you, should be on the inside of it. So all you have to do is just take those two numbers and just multiply them together. So it's 11 times pi over 2, which is just going to be 11 pi over 2. And for these, they'll give you the angle in terms of pi. They'll give it to you in a radian measure. So that's it. So you got to do. And your intercepted arc basically is telling you, all right, what's the distance from here to here? Because you're finding the arc distance is basically what you're doing in this case. Again, if you leave it in terms of pi, that's going to give you a distance measurement when it comes off of this thing. And there's nothing really more to it than that. They'll just So I have like 5 pi over 4 here, and then your radius is 8. again, just take the two numbers and multiply them together. It's 5 pi over 4 times 8. In that case, you do get that if you've got the 5 pi over 4 and the 8, you can cancel the 4 and the 8. So then it's just 5 pi over 2, which is 10 pi. Did you do like multiply straight across and then simplify? Yeah, works the same way.